Beat frequency. Beats are created through constructive interference of sound waves. They are the periodic changes in the sound intensity caused by interference between two nearly identical sound waves. So when you get into class, I'm going to demonstrate this for you. So what I do is I have two tuning forks that are only 2 hertz apart, and I strike both of them. And what you actually hear is almost like a wow sound. It kind of sounds like this, like wow, 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 wow. And I promise I will actually demonstrate this for you. Let's talk about what's happening though. So if I have a tuning fork that's 16 hertz and one that's 14 hertz. So what that means is I'm going to have 16 waves every second and here 14 waves every second. And I've actually drawn this out. So R stands for refraction, C is compression. So that's one wave. So I have 16 of these. And in the other one, I have 14 compression, refraction. And what we see is when we have a refraction and a compression, they cancel each other out because they're opposite. We end up with a very, very low sound. However, eventually the refractions line up and they add together and we end up with a really loud, intense sound. So this is how loud we hear it. If we keep going, well, refraction, compression, they cancel out yet again and the sound gets quieter and then it repeats. So this is that wow, wow, wow sound you get. And one of those wows is considered a beat. So when they're 2 hertz apart, you actually hear 2 beats. You hear 2 of those wow, wow type of sounds. So beat frequency is the number of beats heard per second, and it's a frequency, so it's measured in hertz. And we have 2 formulas for beat frequency. One, beat frequency is the number of cycles divided by time. That's just our frequency formula. That's nothing new. This one is new. So beat frequency is also equal to the absolute value of the first frequency subtract the second. So up here, when they were 2 hertz apart, well, 16 minus 14 is 2. I already knew I was going to hear 2 of the beats. The other thing to note is these are absolute value signs. So that means if I went 14 minus 16, I still only hear 2 beats. The negative doesn't matter to us in this case. A tuning fork with a frequency of 256 hertz is sounded together with a note played on a piano. 9 beats are heard in 3 seconds. What is the frequency of the piano note? So that's the second frequency. So let's write down what we know. It says a tuning fork with a frequency of 256 hertz. That is our first frequency. So our first frequency is 256 hertz. Sounded with a note played on the piano. So that's what I'm looking for. I'm looking for that second frequency. I don't know what it is. 9 beats are heard. Well, 9 beats is the number of cycles. So I hear that wow, wow, wow sound 9 times. So I know the cycles, which is equal to my beats, is equal to 9. In 3 seconds, I know my time. Time is 3 seconds. And again, I'm looking for that second frequency. Well, I have 2 beat frequency formulas. The first one is beat frequency is equal to cycles divided by time. And it's not a new formula. We always knew that frequency is cycles divided by time. So we can calculate the beat frequency. So that would just simply be 9 divided by 3 is 3 hertz. My other formula for beat frequency is beat frequency is equal to the first frequency subtract the second frequency. And I want to take the absolute value of that. Absolute value signs basically say whatever this number is, make it positive. So if it's positive, it stays positive. If it's negative, well, just make it positive. So let's figure this out. I know the beat frequency is 3 because I've calculated that already. I know my first frequency is 256, subtract my second frequency. So basically, I want the difference to be 3. And that's pretty easy to do. I can say that F2 If I go 3 less than this number, 253 hertz, because 256 minus 253 will give me 3. Or I could go 3 greater than this number. If I go 3 greater, it'll be 259 hertz. So if I went 256 minus 259, that gives me -3, and the absolute value signs mean I just make it positive, so it becomes +3. So there's actually 2 possible answers here. So the piano could either be at 253 hertz or 259 hertz.